Welcome to the deep dive. Today we're getting into a mathematical invention that, and this is no exaggeration, unlocked the entire age of science.
We're talking about logarithms.
Exactly. A kind of intellectual shortcut that completely redefined what was possible for human calculation.
And to really get why it was so revolutionary, you have to picture the world back then. We're
Yeah.
talking the late 16th, early 17th centuries.
The great age of navigation.
Precisely. And that age had a huge bottleneck. I mean, a massive one. It all came down to basic arithmetic.
Things like astronomy and navigation, they were just paralyzed by the math. Spherical trigonometry, right?
Yes, and that sounds complex, but the real problem was simpler. It forced astronomers to multiply and divide these enormous
They're
numbers,
like 10, 12 digits long.
at least. And they were doing it by hand. So if you make one tiny mistake across hundreds of steps,
Your whole calculation is worthless.
completely. Johannes Kepler famously called his struggle with planetary data the war with Mars.
And he actually estimated, didn't he, that logarithms could have cut years of his work down to just a few hours.
It's an incredible thought. This wasn't just a math problem. It was a genuine blockade on progress.
So that's our mission for this deep dive. Unpack the technical leap that solved this crisis and, look at the impact it had.
And it all starts with one person, a Scottish mathematician named John Napier.
Napier. He'd already invented Napier's bones to help with counting, but this was his life's work.
It took him 20 years, and his breakthrough was seeing that you could replace the impossible task of multiplication with the easy task of addition.
But how? I mean, they didn't really have the concept of exponents to work with, did they?
That's the genius of it. No, they didn't. So Napier came up with a conceptual map. He imagined two sequences of numbers.
Okay.
One increases arithmetically, so, 1, 2, 3, 4, a steady pace.
Simple and linear.
The other increases geometrically or exponentially. It speeds up. He found a way to link the two.
So you could just look up the log code for your two big numbers, add the codes, and that sum would point you right to the final answer.
That's the core idea. He spent 2 decades building those tables, an estimated 10 million calculations to get it done.
And in 1614, he published them, coining the term logarithm.
From the Greek for ratio and number.
So his tables were a marvel. Astronomers adopted them almost instantly. But like any big invention, it needed a version 2.0.
It did. The initial system was a bit clunky. For one thing, the logarithm of 1 wasn't 0, which made it hard to use.
Which brings in Henry Briggs.
Yes, Briggs visited Napier, and he saw a way to make the whole system universal, to make it truly practical.
His idea was to align it with our decimal system.
A simple, beautiful proposal. Let's just switch to a base 10 system. Make the log of 1 equal to 0 and the log of 10 equal to 1.
And Napier agreed. So Briggs took on the huge task of recalculating everything into these new common logarithms.
By 1624, they were published. And that was it. That became the standard for the next 300 years.
The impact must have been immediate.
It was. Kepler, for one, embraced them instantly. Logarithms were absolutely instrumental in him proving his third law of planetary motion,
And for creating his famous Rudolphine table.
which were the most accurate astronomical charts for over a century. It really made celestial mechanics possible.
And beyond the stars, this tool simplified navigation, surveying. Basically any field that needed heavy calculation.
But what's really fascinating is how the idea is still so central today. Logarithmic scales actually match how we perceive the world.
You mean we don't experience things linearly?
Not at all.
Ugh.
Think about sound or light. We perceive them exponentially. That's why we use scales like the decibel for sound or pH for chemistry.
And the Richter scale for earthquakes.
Exactly. They all use logarithms to manage these huge ranges of data in a way that makes sense to us.
So even with all our computers, the concept itself is still fundamental. In statistics, computer science.
It's everywhere. Logarithms were the ultimate shortcut. They turned years of calculation into hours and really made the age of science possible.
So here's a final thought for you. Logarithms don't just solve math problems. They seem to be the actual language that models nature itself.
Right. They translate the exponential relationships all around us into something linear, something our minds can grasp.
From how we hear a sound to the incredible power of an earthquake. They're like a blueprint for the exponential universe.